Inside the acoustics system's chamber, acoustic wedges are designed to absorb and diffuse acoustic energy, eliminating acoustic reflections and creating a free field measurement environment inside the chamber. This free field measuring environment is the ideal environment for making accurate and repeatable measurements. Outside the measuring environment, we're subjected to external noise such as traffic, internal machinery, even people working in or near the vicinity. And without adequate isolation, these external noise sources would be present inside the chamber, influencing the measurements. Therefore, we need to significantly reduce these external noises entering the measuring environment. After all, we only want to measure the acoustic energy radiating from the products we're testing and nothing else. Testing products to an industry-published standard is often a requirement. These standards describe the appropriate test procedures, equipment and calibration requirements for obtaining the accurate and repeatable measurements. Regulatory requirements define maximum noise level limits measured using these standards. Now that we have our ideal free field measuring environment, isolated external noise sources and know what standards we're going to use to test the product to, we're ready to start taking some measurements to determine the sound power levels emitted from the device under test. The Nelson Acoustics Trident software is a tool we use for taking these measurements. The Trident software measures the sound pressure levels and exports the data so the necessary calculations to give us the end result as a sound power level can be performed. In the chamber, we place an array of brass microphones that envelope the product and measure the sound pressure levels over a predefined surface area. These brass microphones are attached to cables that lead out of the chamber to our National Instruments data acquisition system. The product we're testing is placed inside the acoustic chamber and the doors are closed. Before we measure the actual sound power generated by the product, we must first measure the background noise levels inside the chamber. This measurement is stored as our ambient data. Next, the product under test is switched on and another measurement is taken. This time the measurement is stored in a separate worksheet as the DUT data. Using these measurements, we can determine the sound power level emitted by the product. The data from our measurements are linked to another worksheet, where the calculations are performed to give us the end result as a sound power level, typically expressed as an air-weighted level in decibels. This sound power level is then compared against the maximum allowable levels allowed in the regulatory standards to determine whether or not the product is compliant. From acoustic measurement hardware and software to a full acoustic test laboratory, ViAcoustics' mission is to provide a complete array of products and services to address product noise and acoustic measurement applications. For more information, visit our website at www.viacoustics.com.